All right, let's learn about functions. So we're going to ask ourselves and answer this question. What's a function? We're going to learn how to determine whether relations are functions. We'll talk about what relations are too. We'll talk about finding the domain and range of a function, and we'll talk about identifying independent and dependent variables of functions. So a relation is just basically like a rule or a mapping that pairs inputs with outputs. So like a certain input will be related to a certain output. When a relation is given as ordered pairs, so ordered pairs are x comma y. The x coordinates are the inputs, and the y coordinates are the outputs. A relation that pairs each input with exactly one output is called a function. So for a function, each x value can only be correlated to one y value. You can't have one x value trying to go to two different y values. Can't give you two different output values. So that's what a function is. A function is when each input is paired with exactly one output. So first, let's take a look at this problem and try to figure out which of these are functions and which are not. So here, they're listed as ordered pairs, right? And so we need to look at the inputs and the outputs. And as long as we don't have one input going to two different outputs, then it's a function. So here's our inputs. We got -2, -1, 0, 1, and 2. All of our inputs here are different, right? We don't have the same input showing up twice. So we don't even have the possibility for an input to be paired with two different outputs, right? The only thing that -2 is paired with is that +2. The only thing that a -1 input is paired with is that output, a +2. The only thing that the input 0 is paired with is 2. The only output that 1 is paired with is 0, and the only output that 2 is paired with is 0. As long as this is a function. The way that you'll see in part B when you'll be able to recognize when something is not a function. So if you look at part B, we have, if you look at just the input 4, we have the input 4 showing up twice. But each time it's getting paired with a different input. First time 4 is getting paired with 0 as an output. The second time the input 4 is getting paired with 3 as an output. We can't have that in a function. So this is not a function. Basically, all you're ever looking for when you're determining if a relation is a function is, do you have one x value trying to get paired with two different y values? That's what we can't have in a function. So let's look down in this little chart for C. We've got the only input that shows up twice is 0. Once 0 is getting paired with 5, and then the other time 0 is getting paired with 6. Since the input 0 is not paired with exactly one output, this is not a function. Func. There's a C in there. And then here's another way to show. Here's our inputs. -1 is only being mapped to one output. 3, the input 3 is only being mapped to one output. And 11 is only being mapped to one output. So since each input is paired with only one output, this is a function. It's okay that two different inputs go to the same output. That's okay. We had that up here too. We had -2 and -1 and 0 all paired with the output 2. We had 1 and 2. Those inputs were both paired with the output 0. That's okay. You're just not allowed to have one X value, one input, being paired to 2 different outputs. All right, so take some time to determine whether these are functions, and then you can check. And if you get questions about these, you can ask during class. So this first one is not a function because you have 5 getting mapped to 0, and then you have 5 getting mapped to 10. Number 2, we don't even have the same X value show up twice, so there's no way it can get mapped to 2 different functions or to do 2 different outputs. So this one is a function. Each input is paired with exactly 1 output. On number 3, the same, you don't even see the same input show up twice, so this one has to be a function. Because remember, the only thing that would make it not a function is if you have the same input getting mapped to 2 different outputs. Here you've got the single input 1/2 getting mapped to 3 different outputs. That you have 1 input getting mapped to 3 different outputs. That's not a function. Each input is only allowed to get mapped to exactly 1 output. So graphically, we can use what is called the vertical line test, which is just a visual way to see if a single input has more than 1 output. You imagine passing a vertical line across the graph, and if that vertical line ever touches the graph in 2 spots at once, that's not a function. Because what you would have there is 1 input value, whatever that number is, getting mapped to 2 different Y values. Right? So this would be a case where you don't have a function because 1 input is mapped to 2 different outputs. So as long as no vertical line can ever touch 2 points on the graph, then it's a function. And if a vertical line can touch 2 points anywhere on the graph, it's not a function. So look at this. Determine whether each graph represents a function. So for part A, you're going to visualize a vertical line passing over the graph, and you're going to look for any spots where a vertical line would touch 2 points at the same time. There were a couple of spots right here and right here. So, and for A, the input 2 is being mapped to 2 different outputs, 2 and 5. So you would have 2, 5 and 2, 2, right? This point right here is 2, 5. This point right here is 2, 2. And there you can see that you have the input 2 being mapped to 2 different outputs. So that's not a function. And you wouldn't have to really write the 2, 5 and 2, 2. I just wrote that to show you kind of the points and the inputs. So anytime a vertical line would touch 2 points on a graph, it's not a function. So you can visualize over on this graph, there's really no place anywhere you put a vertical line that it's going to touch the graph in 2 different spots. This one never, no vertical line can touch the graph in 2 spots at once, so this is a function. Okay, so now let's think about this. Number 5. No vertical line is ever going to touch 2 of those dots at once, so that's a function. Number 6, no vertical line is ever going to touch this at two spots at the same time. This one's also a function. Number 7, there's a lot of vertical lines that could touch in 2 places, right? There's one there. You only need 1 example. This is not a function. And there's no place on this graph where a vertical line is going to touch twice at the same time, so this one is a function. Domain and range. The domain of a function is the set of all possible input values. The range of a function is the set of all possible output values. So if you look at this function, y equals 3x, all it says is you take the input x, multiply it by 3, and that's your output. Well, how many numbers can you multiply by 3? All of them, right? You can multiply anything by 3. So this function, y equals 3x, would have a domain of all real numbers. And a range also of all real numbers. Because any number, you can multiply any number by 3. You can also get any number by multiplying by 3. Let's look at some examples. So what is the domain and range of these functions? So this first one just has 1, 2, 3, 4 dots on it. So this one is going to be just like the only possible input values are, now these are the x values, right? So what I'm going to do is I'm going to go ahead and write the coordinates of each one of these points. So this first point is -3, -2. This one is -1, 0. This one is 1, 2. And this one is 3, 4. So to find the domain is the set of all the input values. So we only have 4 input values, -3, -1, 1, and 3. So the domain, this is how you write the notation for a set. You just do a curly bracket. And then you can just list the members that are in the domain. -3 is in the domain, -1 is in the domain, 1 is in the domain, and 3 is in the domain. Then to find the range, it's just a set of all the possible output values. Well, those are the y values. So the possible y values are -2, 0, 2, and 4. So there's the domain and range of this function for A. What about B? Well, B is a little bit different, right? Because on A, there was just only 4 x values that could even work. But on B, it's every x value from -2 all the way over to +3. Right? So your domain is going to be every x value from here over to there. So your domain is, and you can write this with an in-between statement. It's the x values are all in between. Remember, we do an in-between statement with the lowest number on the left. So that was the lowest x value is right here at -2. So -2, and it has a solid circle. So -2 can actually be an x value. So we need to do less than or equal to x. Less than or equal to, the highest value it could be is 3. So the domain is every x value from -2 to 3, including -2 and 3. And then the range, similarly, is every y value from -1 up to +2. So our range goes from -1 up to 2. So -1 less than or equal to y less than or equal to 2. Notice the domain is always x's. The range will always be y's. Okay, try these. Pause and then come back and I'll tell you the answers. So the domain of the first one is, we only have 5 values, or we only have 5 x values, right? So -2, -1, 0, 1, and 2. The range, the lowest y value we have is 0. We have a couple of points that have a y value of 2. We have a couple of points that have a y value of 4. Those are the only 3 options for y values. So that's the domain and range for number 9 here. Then for number 10, your domain is going to be from here to there, left to right, right? Everything from 1 to 5. So the domain is 1 less than or equal to x less than or equal to 5. Our range, the lowest y value is right here at 0. The highest y value we have is 4. And it can take any y value between there, right? Anywhere you look here, boom, you got a point that's going to have that y value. So that's your range and domain for number 10. Now we're going to talk about independent and dependent variables. So the input, and I kind of honestly, I just remember it like this. Input is independent. That's what goes into the function. The output depends on what the function does to the input, or it depends on what the input was. So the statement y is a function of x means that y varies depending on the value of x. So y is dependent on the independent variable x. Our input is always going to be the independent variable, and our output is always dependent. Depends on what the input was. All right, so here's a function, y equals negative 3x plus 12. It represents the amount y in fluid ounces of juice remaining in a bottle after you take x gulps. So identify the independent and dependent variables. The independent variable is going to be our input, which is it's x, which the variable actually isn't the letter x. The variable is the number x, which represents the number of gulps you take. The dependent variable, y, is the amount of juice left. Then they tell us, so those are the independent and dependent variables. The independent variable is the number of gulps taken. The dependent variable is the amount of juice left, because the amount of juice left depends on how many gulps you've taken. Okay, so the domain is 0, 1, 2, 3, and 4. What is the range? Well, we can find that out if we know that the x values are 0, 1, 2, 3, and 4. All we have to do is figure out what y is, and y is negative 3x plus 12. So we just need to do negative 3x plus 12 for each one of these. So for the first one, when x is 0, y equals negative 3 times 0 plus 12. Negative 3 times 0 is 0. So this is 0 plus 12, which is 12. So I know 12 is going to be in my range. When I use the input 1, y equals negative 3 times 1 plus 12. That's negative 3 plus 12, which is 9. And we just keep going. When y is 2, I'm going to have to readjust my column here. When y is 2, we're doing negative 3 times 2 plus 12, which is negative 6 plus 12, and that is 6. When x is 3, we're doing negative 3 times 3 plus 12. That's negative 9 plus 12, which is 3. So after you take 3 gulps, there's 3 ounces left. And then when x is 4, we're doing negative 3 times 4 plus 12. That's negative 12 plus 12, which is 0. So our range is the set containing these values: 0, 3, 6, 9, and 12. All right, so you got a couple of these to do. Let's see. A is the number of avocados you have left after making B batches of guacamole. So the number of avocados you have left depends on how many batches of guacamole you've made. So the independent variable is our input. B, batches of guacamole. B, the number of batches of guacamole. The dependent variable is A, the number of avocados left. If the domain is 0, 1, 2, and 3, what would be the range? Okay, so when we plug in a 3, our range, the output would be 2. When we plug in a 2, that would be -8 plus 14, so 6. If we plug in a 1, that's -4 plus 14, so 10. If we plug in a 0, that's 14. So there's your range. And for the last one, our independent variable is going to be our input, right? That's where the x would go. But if you think about it, the temperature of an oven depends on how many minutes it's been preheating. So the independent is m minutes of preheating. The dependent variable is T, the temperature. And the recipe calls for an oven temperature of 350 degrees. Describe the domain and range of the function. Okay, well, the domain is going to be, what's the lowest amount of minutes that you could have it preheating for? 0. So from our domain, 0 is going to be the smallest. M. And then we need to figure out how many minutes would it take to get to 350. Temperature of 350. So that means we could plug a 350 in for T. So if 350 is T, then what was M? 19M plus 65. I can solve for M by subtracting 65 from both sides. Bring up a little calculator. 350 minus 65 is 285. We can get M by dividing both sides by 19. So 285 divided by 19 is 15. So it would take 15 minutes to preheat to 350 degrees. So our domain would be 0 less than or equal to M less than or equal to 15. And our range would be, lowest it would be whatever room temperature is. So I'm going to say in my house, it's 78 degrees would be like the starting temperature about. Less than or equal to T, less than or equal to 350, which would be the max temperature.